everyone, today I would like to work this area worksheet that I have shown you. This is again a worksheet that I would probably typically do in one of my classes. So first let's work on finding the area of an irregular region. With this we have to understand that one of these blocks is going to represent 1 unit squared. So all I really have to do is count the blocks. I can go through and I can count them maybe quicker if I group them together. So this looks like a 3 block by 3 block area. So this represents 9 blocks. Maybe I can now group this section of blocks together. 5 there. Over here, I'm going to have a group of 3 whole blocks. But this isn't just about whole blocks. I also have half blocks in here as well. If I add these half blocks together, I get another 1, and adding these half blocks together, I get another 1. So adding my 9 plus 5 plus 3, that's 9 plus 8 is 17, 18, 19, I get that the area of this irregular region is 19 units squared. How about a triangle? Well, with a triangle, the formula for the area is 1/2 base times height. In here, my base is this line, this segment right there. So that makes my base 5, and my height is this dashed line here marked as 3. So the area of this triangle is 1/2, 5 times 3. Half of 15 is 7.5, and now I've got a unit. I don't just have to do unit squared, 7.5 meters squared. So what's next? This parallelogram. I have an area formula for a parallelogram is just base times height. But really the question is, what's the base and what's the height? Here, my height is given by this dashed line. See, it makes a right angle, that makes it the height. So that would be 4 centimeters, and my base then would be the one that's perpendicular to that, which is 5 centimeters. 5 times 4 is just 20. So this is 20 centimeters squared. What's the formula for a trapezoid? Well, this is 1/2 height, where I add base 1 plus base 2. So here, the height again is the line that makes the right angles with my bases. So my height is 7. My bases are 14 and 10. When I do this math, 14 plus 10 gives me 24. Half of 24 is 12. 12 times 7. That's where I'm getting the 84 centimeters squared. How about the area of a circle? Well, the area of a circle is just pi r squared. My radius is given, so this would be 25 pi. That's an exact answer. Centimeters squared. Sorry. That's an exact answer. But if I wanted to get an approximate answer, I could actually multiply 25 times 3.14 and come up with around 78, 79. But no one asked me to get an estimated answer, so I'm leaving my answer in the exact form. What about a sector? Well, this is just part of the entire circle. How much of the circle? 60 divided by 360. How do I know that? Well, the sector angle here is 60 degrees. The whole circle is 360 degrees. So the fraction of the circle that's represented is 60 over 360, or 1/6. 1/6 of what? Pi r squared. Here my radius is 4, so this will become 1/6 times pi times 16. Now you can simplify that 16 and 6 by 2, and that's where I came up with my 8/3 pi centimeters squared. When we get compound areas, or areas that are added together, it's easiest to break these up into 2 shapes. Now, different people break these in different ways. To me, it looks like kind of the obvious way to break this might be into a rectangle and a triangle, but I don't have to break it that way. I could have broken it into 2 trapezoids. I could have maybe done an extension here and subtracted rather than added, found the area of the entire shape and then subtracted out those 2 triangles. But I'm going to go with my original method, which is to break this into a rectangle and a triangle and add those 2 shapes together. This bottom rectangle is a 6 by 9, and 6 times 9 is 54. I don't know the units, but I know it's units squared. How about this triangle? Well, the base is 9. I'm just bringing this 9 up because this base of this triangle is the same length as this one for the rectangle. But what's this height? Well, to find the height, I have to take the 10 minus the 6. 10 minus 6 is 4, so this is just 1/2 base times height. So 9 times 2 is 18. That's 18 units squared. So if I add my 54 to my 18, I come up with 72 units squared, showing that I can add those areas together. How about a subtracted area? Here, I'm going to take the area of this circle and I'm going to subtract out the area of that triangle. Well, the area of a circle is just pi r squared, and in this case, my radius is 10. So I have 100 pi. But what's the area of that triangle? Well, it might help me to draw in the radius a little bit differently. If I drew this radius here, that's 10. That gives me my height. And then I can draw the radius twice here, or a diameter. That gives me my base. So my area of a triangle is 1/2 base times height. In this case, it's 1/2 of my 20 times my 10. I have 100 pi minus 10 times 10, or 100. 100 pi and 100 aren't like terms, so I can't put them together. So I could just leave it as 100 pi minus 100 centimeters squared. But one of the things I did in the answer key was that I actually multiplied that pi out, and I got an estimated answer of 214 centimeters squared. How about a rhombus? Well, you can treat a rhombus like a parallelogram, but you can also treat it as its own thing, which is a rhombus, or 1/2 d1 d2. The note that I have below this right here says that the numbers 10 and 14 and 6 and 8 in the kite refer to the entire diagonal. So that means that this 10 is the entire diagonal, and this 14 the entire diagonal as well. So the area formula for a rhombus using the diagonals is 1/2 d1 d2, or 1/2 10 times 14, or 5 times 14, which is where I got 70 square units. Here with my kite, again, 1/2 d1 d2. I'm reading my note below. It says it refers to that entire diagonal. So I simply take 1/2, 8 times 6, or 4 times 6, which gives me my 24 centimeters squared.